So we're going to do 1-3, all of 1-3. We split up 1-2 into 2 days, but 1-3 we do in 1 day. So we're going to do some algebraic expressions. Algebraic expressions. These are not equations. We're not solving for x. An expression is kind of something that just sits out there and you can simplify it, but you don't solve it. Algebraic expressions. I hope I spelled that right. I'm probably the worst speller in the world. Ugh.
Besides the literate people.
Well, yeah, okay. Maybe I exaggerate. All right, we have 3 parts today, A, B, and C. All right, first part, we're going to do some modeling. Not that kind. We're going to do some mathematical modeling, which is not as hot, I guess. Okay, here we go. So modeling this book, when Common Core came out, we were like, ooh, nobody likes Common Core, right? It was like, yuck. But a lot of it is has to do with modeling, like translating English into math. So that's what we're going to do. So here we go. Number 1. We are going to write an algebraic expression, right? An algebraic expression. Here we go.
Seniors with last names G through O. Seniors last names G through O.
Do you think they did the juniors already?
They skipped us.
They skipped juniors. Okay, they'll figure that out. All right, write an algebraic expression. Write an algebraic expression. Not S. Okay. If you don't know what an algebraic expression is yet, you're going to see what it is right now. Here we go. Okay, I'm going to give you an English sentence, and we're going to write it into math terms, math symbols, okay? So something like this. 7 fewer than t. 7 fewer than t. All right, there now this doesn't really mean much, but we're going to need to translate these things so that we can do other problems later on. So what is 7 fewer than t? It's a little tricky. Perfect, it is. It's t minus 7. T minus 7. Okay, in that order. Not 7 minus t, t minus 7 for sure. All right, so here we go. Another one. B. How about, ooh, this one's tricky too. 2 times, okay, we know what those words mean. 2 times the sum of A and B. Two times the sum of A and B. So these are English words. We're going to translate. You know, math, I always think math is its own language, right? It's like symbols. It looks weird. We actually have abbreviations like symbols for big words. Like, for example, the word therefore is abbreviated with 3 dots like that. When you get into like proof and stuff later on. I know, right? Who came up with that? You write therefore, this is this, and you just do that instead of writing the word therefore. Okay, so 2, we all know what 2 is a math symbol. 2 times the sum of A and B. So what are we going to do? Yes, we're going to put parentheses around the sum of A and B. So 2 times the sum of A and B. We're modeling, yes. We're modeling well. Okay, yeah.
Thank you.
Okay, how about this one? Two more of these. How about, here's a real life situation. Let's say you start with $100. This isn't my real life. It might be yours, but all right. You start with $100, and you are going to save $5 per week. And we need to write this as an algebraic expression. See what I mean by expression? An expression is just something that has no equal sign. It doesn't really do anything. It just kind of sits there, right? Like a baby. Okay, start with $100 and save $5 per week. So how would we write that? 100? Perfect. 5W, 5X, 5M, whatever you want to do. So if you want to find out, for example, how much money will we have in 4 weeks, you can plug in 4 for W, right? Okay. It's so easy, right? Don't you love the beginning of school? No. Okay. How about the other way? Let's say that you had $30 and you decide to spend $2 per day. Okay, go ahead and do this one by yourself. Try it out. See if you can do it. You had $30, or you have $30. Don't worry about the word had. $30, and you're going to spend $2 a day. Maybe you want to buy cookies or donuts or whatever. $2 a day. Maybe you pay someone to do your homework for you. $2 a day. I don't know. All right, what do you got?
30 minus 2D.
Perfect. 30 minus 2D. Nice. All right. I'm insulting your intelligence, right? You're like, come on. Yeah, I thought so. All right, we'll do some harder ones. Here we go. Part B. So now that we know how to get the English words into math symbols, let's go ahead and do some just math symbols and stuff. So we're going to do something called evaluate. Evaluate is just a fancy word for plug it in. Okay? We're going to do some plug it ins. And we're going to be given an algebraic expression with variables. And those variables are going to be given to us as numbers, and we'll plug them in and evaluate the expression. So here we go. Number 2. So evaluate. We're still not solving. We're not going to do equations yet. Not until I think 1-4, maybe tomorrow. Equations? Yeah. We're just doing expressions today. So here we go. Letter A. Let's take 7 parentheses A plus 4 close parentheses plus 3b minus 8. All right, so that's an algebraic expression, and I want to evaluate this when A is equal to -4 and B is 5. Okay, you may use a calculator if you want to. You don't have to, okay? And I'm not going to take it away from you saying you have to do it by hand. It's up to you. Now, if you get a graphing calculator like this graphing calculator, you have to have one, but pretty soon. It has parentheses on it, so you can just plug everything right in. And this calculator knows PEMDAS. Do you know PEMDAS?
Yeah.
Please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract. That's the order that you do things in, okay? Your calculator will do it for you. Now, let's say we don't have a calculator. Ooh, a lot of you do, though. Good. That's real good. What'd you get? You got it already? Okay. All right. So here we go. Let's try it. I'm going to go ahead and plug these numbers in for A and B and go from there. So I have 7 times -4 plus 4. Ooh, that's going to be fun. Plus 3 times 5 minus 8. All right, now using PEMDAS, if we're going to do this by hand, we need to do parentheses first. So this is going to be 7 times 0 plus 3 times 5. Did you get it wrong?
No, I misread the parentheses.
Oh, okay. And then minus 8. So 7 times 0 is 0. 3 times 5 is 15. 15 minus 8, the answer is 7. Yay. 7. Okay. Now, let me show you real quick on the calculator that you could have just plugged it in. These calculators are great. I mean, you're not thinking, but it's okay for something like this. So you would go 7, and there is a parentheses button. And you can go -4 plus 4, close parentheses, plus 3 times 5 minus 8. Hit enter, and it'll give it to you. It does PEMDAS for you. I know, isn't that cool? You're going to love this thing. All right, here we go. Next one. Letter B. This one. X divided by 2 plus y squared. X over 2 plus y squared. Okay, and we're going to say that x is equal to 1 and y is equal to 1/2. Now, you can do this in your head, probably. You can do it in your calculator. You have an old calculator, you can still do that. So let's go ahead and plug everything in. We're going to evaluate by plugging in and finding a number answer. So 1 goes in for x, so I get 1/2. 1/2 goes in for y, and so that's going to be 1/2 squared. Now you have to be careful on this one. If you're going to do this in your new calculator, you need to put parentheses around the 1/2 and square it, okay? So I would go parentheses 1/2, or you could just do 0.5, because you know that 0.5 is 1/2. And then the squared button is right here. It's the x squared. So this is why it's really important that you get these soon, so that you start knowing the buttons. Do you see this over here? Do you know what that's called? This little mountain peak? It's exponent. It's called a caret. They call it a caret. So this is like you can do that and then squared it. Or you can just put x squared. And it'll give you 0.25, which is 1/4, right? Okay, but see, you don't even need that. So you go to here and you go 1/2 plus 1/4. What is 1/2 plus 1/4? 3/4, yeah. Did you ever do any baking? 1/2 and 1/4, yeah, 3/4. By the way, one thing you're not going to really appreciate or like about these calculators is they don't do fractions the way you used to do them on your old calculator. Fractions on here use the division symbol. So 1/4 plus 1/2, oopsie. And it'll give you 0.75, but there's a button. It's underneath math. And do you see how it has a little arrow fraction? It means it's going to take your answer and turn it into a fraction for you. And it'll give you 3/4. I know, yes. So you'll like that part. Okay. All right, let's move on. Let's do another one. Letter C. 2 times x squared minus y squared, in parentheses, all divided by 3. And we're going to do this when x is 6 and y is -3. All right, we're going to be careful on this one. Okay? Oh. So let's go ahead and plug our stuff in. So we're going to go to...
All seniors that have not had their pictures taken, please come to the attendance office. All seniors who have not had their pictures taken, please come to the attendance office. Thank you.
2 times 6 squared minus, now -3 is being squared, so you know what you really need to do is you need to put that -3 into parentheses. Do you know what -3 squared is? It's +9, right?
Yeah.
Okay. Your calculator, if you write -3 squared, your calculator will tell you it's -9. Okay? And I'll tell you why. Yes. No, the calculator's not wrong. You're wrong. If you put in -3 squared, you're squaring the 3 and putting a negative in front of it. If you want to do -3 squared, you have to put parentheses around it. Then your calculator will tell you it's 9. So sometimes it's better to do it like on your own because you know what it is. You know -3 squared is +9. Okay? All right, so let's go keep going. Let's simplify this. Do you know what 6 squared is? 36. Good. Minus 9 over 3. Okay? Keep going. 36 minus 9? 27 over 3. And you can go 2 times 27 divided by 3. Or you can go 3 goes into 27. 9 times 2, 18. Good. 18. Try to put like a circle or a box around it when you get the correct answer. Okay? All right, let's do one more. I'm going to let you try this one by yourself. This one's kind of cute. All right, let's do, yeah, it's cute. M squared minus 12, and m is the square root of 7. This one's cute. All right. This you can do, you know, just without a calculator. You can do this in your head probably. I hope so. I think so. I haven't done square roots in a while, but maybe you remember. What'd you get? -5. Good. Anybody else get -5? You're like, yeah, what he said. Good. Okay. So square root of 7 squared minus 12. So the square root and the squared, they just kind of cancel each other out, don't they? And you get 7 minus 12 is -5. Good job, you guys. All right, we are down to the nitty-gritty. The last one, letter C. Anybody play HQ? I won $2.03.
I won twice. I won $23.
You've won twice? How much?
$23.
Shut up. All right, so here we go. Last part. We're going to do some combining now. So we're not going to evaluate. We're not going to plug numbers in, but we are going to combine. But we need to know a couple of things before we combine, because I'm going to use some words that are, maybe you need to know what they are. So I'm going to say the word term. I'll say term sometimes. And a term is going to just be, it's simply either, oops, I don't want to do that. It's simply either a number, a term could be a variable, or it could be the product of both. Product means multiply. Okay? So that's what a term is, a term. And then I'll show you an example of it in just a minute. Then we also have a fancy word called coefficient. And you've probably heard this word before, I hope. The coefficient is going to be the number in front of the variable. Okay? The number in front of a variable. We call it the coefficient. It's a fancy word for something so simple. Like, for example, if you have 3x, the coefficient is 3. Okay? If you have y, what's the coefficient of y? It's 1. Yeah, the coefficient is 1. You don't see it there, but it's 1. So the coefficient is just the number in front of the variable. And then a constant, do you know why they're called variables? Because what's a variable? Variable is something that's variable. It changes, right? Like x today is 10. Tomorrow it's 30. Like it changes. A constant is a number that does not change. No variables in a constant. Okay? So let me give you an example. Something like this. If you have 5ax minus 7y plus 30. Okay? That is an algebraic expression. Right now it really means nothing. We don't even know what that is. But they stand for things. Okay? So in this thing, this whole thing has how many terms? How many terms does this have? Has 1, 2, 3. 3 terms. We're going to learn later that this is called a trinomial. Shh, I didn't tell you that yet. I don't want to spoil it for you. All right, so this thing has 3 terms. The last term right here, this is a constant, because that one is the one that doesn't have a variable. Okay, and then we have some coefficients. We have 5 is a coefficient, and -7 is also a coefficient. So those are our coefficients, because they're in front of the variable. So I need you to know these words. I'm not going to quiz you on them, or but I'll say them. I'll say them in class. Oh, we have 4 terms, and you need to know what that means. All right, now finally, what we're going to do with these terms is we are going to have some like terms. Now, not everything can be combined together, right? You know this. You go to the store, and are you going to take apples and bananas and put them in the same bag and weigh them and try and go out the store and try? No. You need your apples separate, your oranges, all that stuff. Like terms are when you take all the things that are the same and you combine them together. So like terms will have the same variable and exponent. That's important too. Same variable and exponent. So like for example, x and x squared are not like terms. They're not. You can't combine them. Okay? All right, here we go. Let's go ahead and do, what number are we on? 3? Look it, that's all we've learned today. So cute. All right, we are on number 3. All right, so we're going to combine our like terms. We're not going to plug numbers in. We're not evaluating. We're just going to combine. How much time do we have? We're doing okay. I've got 3 of these for you. Okay? So here we go. We'll start easy and we'll work our way to a hard one. Let's have 7x squared plus 3y squared plus 2y squared minus 4x squared. Man, you're fast. All right, so go ahead and write that down if you are. And we're going to combine these, okay? Now for these problems, you might want to show a little bit of work, but you could probably do a lot of these in your head. There's going to be one coming up where you would probably need to show some work to get it right. So yeah, let's combine our like terms. So I'm going to go ahead and combine all the x squares together. And I've got 7x squared minus 4x squared gives me 3x squared. Good. And then I also have 3y squared and 2y squared. So that would give me 5y squared. And you can't combine those together. Those are not like terms. So One's x, one's y, even though they're both squared. Do you remember doing this back in Algebra 1? Yes, you love it. Okay, maybe not. All right, let's try this one. Negative 3k plus m in parentheses plus 2 times k minus 4m. So if you can do this in your head, that's pretty good. This one's like borderline. Maybe I should show some work. Maybe I can do it in my head. I like to show work and write stuff out. I'm a pen and pencil or pencil and paper kind of a math person. I cannot do stuff in my head. I can't keep all that stuff in there. There's too much useless knowledge in there. All right, so first of all, to get rid of those parentheses, we're going to take that negative sign and distribute that in. And we're going to take the 2 and distribute it. And you can do that in the same step. So I get negative 3k minus m plus 2k minus 8m. Don't forget to use the distributive property to distribute to both the terms in the parentheses. All right, once your parentheses are gone, we can go ahead and combine our like terms. So I've got a negative 3k and a positive 2k. What does that give me? Negative k. Negative k. So negative 3 and positive 2 give me negative 1. You don't have to write the 1 there. And then I have negative m minus 8m gives me negative 9m. And that's it. What's that? You want to try one? Sure. All right. Last one. You get to do it. No one said that? Oh, I heard that somewhere. All right. Let's go with 10 times 2x. You have no idea. Minus 3y. Minus 5x plus y. All right, try this one. It's a lot like the last one. Try this one on your own, by yourself. Don't shout it out. Don't. Oops, I didn't record that. You have about 12 minutes. Perfect. That's a really